Dear physics aspirants, right now I have the book of physics, and here you will see the figure 313, 314 and 315. The current electricity chapter will be discussed right now, and subtopic will be the combination of resistors, series and parallel form. You can see here, with the help of this content, the current through a single resistor R across which there is a potential difference V is given by Ohm's law. I is equal to V by R. Resistors are sometimes joined together, and there are simple rules for calculations of equivalent resistance of such combinations. You can see a series combination of two resistors R1 and R2. You will see here two resistors are said to be in series if only one of their end points is joined, figure 313. If a third resistor is joined with the series combination of the two 314, you will see, then all three are said to be in series. Clearly we can extend this definition to series combination of any number of resistors. 313, a series combination of three resistors R1 and R2 and R3, you will see here, and two resistors R1 and R2 connected in parallel form, you will see here. Two or more resistors are said to be in parallel form if one end of all the resistors is joined together, and similarly the other ends joined together. Figure 315 will provide you the information what I am asking. Consider two resistors R1 and R2 in series. The charge which leaves R1 and must be entering R2, since currents measure the rate of flow of charge. This means that the same current I flow through R1 and R2 by Ohm's law. Potential difference is R1 is equal to V1 is equal to IR1, and potential difference between R2 is equal to V2 is equal to IR2. The potential difference V across the combination V1 and V2 plus V2, hence V is equal to V1 and V2 is equal to I is whole R1 and R2. This is as if the combination has an equivalent resistance or equivalent EQ, you can see, which by Ohm's law, and R is equal to EQ, V by R, approximate equal, and is equal to R1 and R2. If we had three resistors connected in series, then similarly V is equal to IR1, IR2 plus IR3 is equal to IR1, 2, 3 whole. This obviously can be extended into a series combination of any number of resistors R1 and R2. R1, the equivalent resistance EQ is REQ is equal to R1, R2, and so on is equal plus Rn. Consider now the parallel combination of two resistors, figure 315. The charge that flows in a form, and the left flows out partly through R1 and partly joined R2. The currents IR1 2 shown in the figure are in rates of the flow of charge here. The points indicate, hence I is equal to R1 and I2. The potential difference, you will see, potential even V by the Ohm's law applied, you will see here. And if the consider combinations V was replaced by an equivalent resistance equivalent, V would have by Ohm's law I is equal to V by R equivalent. Hence you will see here, example number given here, we can easily see how this extent of three resistors in parallel. Figure 316, you will see here parallel combination of three resistors R1, R2 and R3, you will see here. And the leftovers is exactly the before. You will see I is equal to 1 to 3, applying the Ohm's law. So Ohm's law is very important for this. The equivalent resistance are equivalent, and these resistance combinations would be and such and that. You will see here the I is equal to V by R equivalent, and hence 1 by R. 1, 2, 3. We can reason similarly for any number of the resistors in parallel. The equivalent resistance of n resistors R1, R2, Rn is here, and this formulae for equivalent resistance can be used to find out currents and voltages in more complicated circuits. Consider, for example, the circuit figure 317. You will see here 317, and you will see there are three resistors, 2 or 3 are in parallel, and hence we can replace them by an equivalent R23 equivalent between point B and C. R23 equivalent, you will see here the circuit now has R1 and R2, R23 in series, and hence the combinations can be replaced by the equivalent resistance. You will see here R123 equivalent if the voltage between A and C is V and circuit current I is given. This formula will be, you will see here, you can see here the figure. We will meet in actions with cell EMF and internal resistance with the help of this figure. We will provide you the information regarding what I am asking. We will meet in action with a lot more. Till then, thank you. Thanks for watching the video.